Alrighty, so welcome back to a bit of review about types of error and power. Now, we were exposed to this in Unit 6 when we were doing inference for proportions. And remember, when we reject the null hypothesis and we assume that the null hypothesis is true, this leads to a type 1 error, which you'll see right here. Now, if we reject the null hypothesis and the null hypothesis is false, we've rejected a false claim, there is power in that decision. Now, if our null hypothesis is true, we should fail to reject the null hypothesis. This leads to a correct decision. And unfortunately, this doesn't have a fancy name. We just call this the correct choice. And then over here, we have that we fail to reject the null hypothesis, but our null hypothesis is actually false. That leads to a type 2 error. Now remember, we either reject the null hypothesis because we have sufficient evidence to prove otherwise, or we fail to reject the null hypothesis because we do not have sufficient evidence against our claim here, against the null value. So we represent these types of errors using the following symbols and probabilities. Now, depending on which error you make based on your decision, right, so we reject, that's typically type 1, or we fail to reject, that's type 2, the consequence of the action always depends on the context of the question. For example, a type 2 error isn't always going to be the worst thing in the world. It all just depends on the context. So your type 1 error is your alpha, which also happens to be our level of significance. Our type 2 error is beta, which happens to be our probability of making a type 2 error. And then power is this inverse of the type 2 error, where it's 1 minus beta. So let's take a look here at this example. So let's take a look at an example here. Suppose that systolic blood pressure is the amount of pressure that blood exerts on blood vessels while the heart is beating. The mean systolic blood pressure for people in the US is reported to be about 122 millimeters of mercury with a standard deviation of 15. The wellness department of a large corporation is investigating whether the mean systolic blood pressure of its employees is greater than the reported national mean, and a random sample of 100 employees will be selected. The systolic blood pressure of each employee in the sample will be measured, and the sample mean will be calculated. If the person's systolic blood pressure is 122 or less, no action is taken. But if a person's systolic blood pressure is greater than 122, treatment using medication and or diet and exercise is to be started immediately. We're going to let mu represent the mean systolic blood pressure of all employees at the corporation. Remember, mu is the true mean systolic blood pressure. So if I were to test this, I'm really testing that the null hypothesis is that there is no difference from 122, and the alternative is that it's greater than 122. So my correct decision, assuming that the null is true, would be that if it's 122, I fail to reject the null hypothesis, I don't do anything. Now, if the null hypothesis is false, such that it is greater than 122, this would lead me to reject the null hypothesis and start treating someone who is suffering symptoms. Now, the errors occur when we flip these decisions. So for example here, in a type 1 error, I reject the null, but the null is true. So here I claim the true mean systolic blood pressure is greater than 122, when in reality it is not. We would give someone treatment that does not require it. So we're going to start treating you, but it's not the end of the world, you just didn't actually need it. Well, in a type 2 error, I fail to reject the null hypothesis, but the null hypothesis is actually false. So I claim that the blood pressure is not different than 122, when in reality it is actually greater than 122. And I now have not started providing treatment to a person who actually needs the treatment. Now looking at these two options, which one is worse? I would argue a type 2 error, since I'm not treating someone with a disease, as opposed to in a type 1 error, where I am treating someone, but they don't need it. Now, what if I make a correct decision? And that brings us back to the power of the test. In the power of the test, I reject the null hypothesis because the null hypothesis is false. And that would look like claiming that the true mean blood pressure is greater than 122, when in reality it actually is greater than 122. So I'm now providing treatment to a person who actually needs the treatment. So these are just some ideas here on power, type 1 and type 2 errors. Now, the power of a test. Remember, there are a few things that we can do to the power of the test to increase or decrease the power. So let's go here to our handy dandy applet. And I'm going to start here, population mean. Suppose my null hypothesis is that we're centered at 0, and my alternative is that we're centered at 1.5. Here are my current probabilities, 5%, 22%, and 78%. Now our first one is if I increase the sample size. So right now I've got a sample size of 30. So I'm going to go ahead and increase to, let's go up to 73. Now, when I increase the sample size, notice my type 1 error doesn't change, but my power increases, and my type 2 error decreases. Now, what if I decrease my sample size to like 20? Now my power has decreased, and my type 2 error has increased. So let's go back to 30 here. So when I increase the sample size, my power will increase, and my type 2 will decrease. Well, let's change our significance level next. Instead of using my alpha of 5%, if I use an alpha of, let's say, 8%, now my type 1 probability has increased and my power has increased. And you'll notice my type 2 error has decreased. So let's go back to 5% to see the original values. 2278. Now if I decrease my alpha level, now you'll see my power decreases and my type 2 increases. So let's go back to 5% here. Lastly, if I decrease my standard error or my population standard deviation, so let's see, if I increase, power decreases, but if I decrease, power increases. So this is just going back to the idea that the further away I am from the null hypothesis, the more power I have in completely rejecting, because now I'm well aware that the truth is not close to 0. The truth is further from 0. And now that I have more distance between the truth, I am seeing the likelihood or the likelihood of my sampling occurring is going to be significantly higher than what we believe to be right here at 0. So let me go ahead and write these in. Give me one moment. So did a bit of a cheat code here, but basically each of these 4 things has the power to literally increase the power of the test. And if the power of the test increases, my type 2 error will decrease. Now, the only one of these 4 that will change the type 1 error is by literally changing the significance level itself. So what's most important is to really know these first 2, the sample size and the significance level. Now, there's going to be a deeper understanding that we'll need, but for the purposes of the AP exam, you can just rely on knowing that increasing the sample size and the significance level increases the power of your test. These 2 are a little less common, but still important to know. Alrighty, so what I'm going to need from you all now, and I already gave away one of the answers, is to pause the video and go ahead and try the next 3 examples. We'll come back together and review whole group. Now, here we have that the null hypothesis is false, and we were going to use a significance level of 5%, and instead we decrease it to 1%. Now, which of the following would be true? Since I decreased my significance level, my power of the test would decrease. And because power decreases, type 2 should increase. So this one would be answer choice E. Next up, the patient does or does not have arthritis. If we're looking for a type 2, here we fail to reject. So we believe that they do not have arthritis, when in reality this claim is false and the truth is that they do have arthritis. So you'll see that's answer choice B. And what's important is to know also and recognize the power of the test and the type 1 error that could happen. So you'll see one of these questions on the AP exam, something like this, where you'll be given a contextual situation or you'll be given a conceptual situation. And the last one, of course, is just another example. They could ask you for type 2, they could ask you for type 1, they could ask you for power. So that's a little bit of review there for our types of error and our power of the test. What's going to happen next is now we're going to enter the realm of match pairs design. Now, anytime you conduct a significance test, there's always room for error, and it's always going to be based on our one sample, the one time we did it. So, as all the consequences of type 1 and type 2 both depend on the context of the question. But that's going to wrap up our review of errors and power, and we are going to now start our inference for match pair designs.